Okay, so welcome everyone to the Java talk today. First of all, please excuse my voice. I got sick yesterday and yeah, it's pretty weird. There are actually a few things I would like to mention before it starts. For all users that will use the feature of screen sharing, please consider using the option better text readability instead of smoother video. This will optimize your results in the end. Also, please remember to follow our rules. Obviously, they are also valid for voice channels. For all users that are using some kind of presentation like PowerPoint or Google Slides, please share them with me in the end when you are finished with your talk. I already sent the agenda to the Java Talk chat. If you haven't already viewed them, consider doing that now. I will still mention you if it's your turn to talk. Yeah. Please remember to stay in your time period. Yeah. I will give you your roles when it's your turn, so you can have permissions to speak and everything. Yeah, I think that's it. When you have any questions, please send them now in the voice channel chat. For stage channels, you sadly can share your screen and can turn on your camera. Okay. So first up is Avacha. Sorry if I didn't pronounce your name right. With generic types. I will give you the roles real quick.
Hello. Pa, 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 pa. Second. Hello. Ta-da. Do you see well? I'm a little bit nervous. I don't speak English very often. Okay. Oh. Okay. Generic types. I will talk about syntax because I'm new to Java and don't know a lot of cool features as graphics or threads as other people will talk about. I will have the next subthemes, why we need the generic types, multiple bounds, the type erasure, the breach methods, and the wildcards. Okay, the goal. Sometimes we need some class which can have some fields or methods which can return or accept different types. For example, we can have such class of blocks which have an object value because every type in Java is inherited from object. And well, we can store everything in that box, a string or integer, everything. And we can create box, put an integer into that, and get this cast, because getValue actually returns an object type. But the problems, we have to write an additional code every time. We have to cast that object every time, and this actually makes code looks bad. And it's unsafe because we can cast the object type to a wrong type and cause a class cast exception, what of course will be a problem. Solution. Actually, ancient programmers before first version of Java actually did such things. They cast object types every time, and they had such code. But after Java 5 was introduced generic types, what makes it all much better. We can add a generic type to class box annotation and have a value of any absolutely type. For example, we now can create a box which can contain specifically only integer or contain only a specific string. And we don't need cast anything now. And we don't need to write an additional code and care about class cast exception or something like that. We can also a little bit simplify code because, yeah, and it's safe. Because now compiler won't allow us to compile code like that, because it's string and we can assign a string to integer variable. Yeah. Methods also can be generic and have different types. For example, here we have class foo, which has static void print, what just prints an object. And we also have a few overloads for that method. Like if we provide a string argument to the print method, it's a string. Or if we provide a list, it will make a different code also. It will be very useful and very easy to use. You can also create a multiple generic types. For example, here we have a print which accepts 3 different arguments types. We don't know which kind of types they will be, but we can use that method on any 3 different types. It's very useful. But here we actually can use object, but never mind. And as I mentioned before, ancient programmers before Java 5 didn't have the generics and did code all that casts and other weird code. So actually generics, it's a feature which makes it all easier, because actually generics will disappear after compilation. For example, such code with our box where we have a generics and very beautiful Java compiler actually will transform to such things of that. And that process called the type erasure. We need always to remember such thing, because any generic types information will disappear after compilation. And for example, in such code won't compile, because here we want to check if some object is instance of a generic type. And in that example, we need that each class of box, which has a different generic type, would have a different is compatible method. And actually, if if it somehow would compile, it would compile to something like that, and all the instance of object, and it doesn't make any sense. So I even forgot about the route types. Actually, because generics is only compile time feature, we can create a generic instance of class without any generic type definition. For example, here we create a box of string with value hello, and after that we create a route box, which hasn't any generic method. That code is absolutely illegal because actually Java compiler makes the same thing during the compilation process. And here, when we call the getValue method of rowbox, it returns object because it hasn't any generics and compiler won't generate any additional code. So we can again throw a class cast exception. And sometimes compiler working with generic types can provide can generate an additional methods to override all at once. For example, we have our old box class, but with additional set value method, which just receives a value and sets a field to it. And we have a chest, which extends the box. And we override the set value method to print a string got a treasure. But if we look carefully, after the type erasure box class will have a set value method which receives the object argument. But we override a string argument method. So if we, for example, put chest in a raw box type, it will call as old set value method of box, and our print line method won't be called. So because of that, so because of that, Java generates a new method to our chest class, which just overrides the old method of superclass. For example, here we have set value object value, and just redirect the code to our normal method. If it would not exist, somehow when we would work with raw types, box could have not a string type. It could have an integer type on any other type, what of course would cause any problems later. Because we can set value without any error, but when somewhere code and a lot of thousands lines after, we can unacceptably get a class cast exception. And we can also mark that some generic type need to be a subclass of something else. For example, here we have an abstract class drink that contain a get name method and a get description method. And after that, we want to create a class cup, which can contain only a drink types. And notice that we can use actually drink methods in that cup class. We can call drink get name and drink get desk in show method. And we also can provide multiple types. For example, we have interface with milk, which just returns milk percent in the drink. And we want to cup to store only drink with milk. So we can provide, make it by writing that word chapter. I don't remember how is it called. Yeah, and notice that order of that extends types matter, because first type is always must be an abstract class or just order class, because if we swap these types, that code won't compile, because drink is not interface and compiler would not understand it. So the first item bound always must be a class, but it can be an interface too. But if you have a class, it must be at the first place. And after the type erasure, this type bounds actually transform to the first bounded type. For example, here our generic type extends a drink first type, and after the type erasure, it will transform to the drink, as you see. And in the show method to get milk person, it needs to cast the wildcards. Sometimes we even do not know the type of the generic. For example, we have a two box with integer and the long. We can also put it in the row box. You see that question mark in the triangle brackets of the box generics. It's actually equal to just a row type, but it won't cause any warnings from the compiler. And as you see it, it's just a row type. But if we, for example, want to create a box number and store it to our box integer is subclass of number, it will cause error, because this classes have a different generic types. So because of that, we need wildcards. So here we say that we need a box with any type, generic type, which extends a number. And after that, we can assign our box with integer to that wild box. And notice that get value method of that box returns actually a number type. So we need to cast if we need to get an integer or something else. Wildcards also have not only extends word, they actually have a super word, which allows to get a super classes of the selected type. For example, here we create a box named wild, which may contain any superclass of integer, and then we can assign a new box with integer, new box with number, and new box of object to that variable. And there won't be any error. And also notice that getValue method returns object type. I can explain it by that inheritance tree. For example, we have number, is superclasses, object and subclasses is integer, long, and double. If we will use extends on number, it will able to store a number and all classes in the right direction. But if we use a super keyword, it will allow to store only a number or any class at the left direction. Object in that case. Okay, I'm all. Thank you all. Yeah. Yeah.
All right. Thank you so much for your talk. I think it was pretty good.
Thank you.
Mm, Okay. Next up, we have actually Andrew with 3D graphics programming in Java. Let me just unmute you.
Hello. All right, nice. Okay, so I'll be doing 3D graphics programming in Java. Contrary to what Avetra is saying in the chat, I can't teach everything in a matter of 10 minutes, but I'll do my best. So let's see, how do I share my screen? I think I can just do that using the normal means. Let's share screen number 1, and I want better readability. All right. So, everyone can see this slide, right? Yes? I'll assume so. Otherwise, someone has to at me or something. Because I just lost my Discord thing. So anyway, I'll be doing 3D graphics in Java, and what that means is basically opening your eyes to how it's done, basically, because a lot of people think that it's some sort of daunting task that is just well beyond the reach of you, no matter what. And the only way to get through to 3D graphics is to use some sort of big game engine like Unity or Unreal. But it's actually not that bad. So, what's actually needed in order to do 3D graphics? Well, it's a lot more than Swing or Java FX, in that you need a variety of libraries and you need a little bit of math skills, and you need to take a little bit more attention to detail on certain things, but it's still entirely doable. So you'll need obviously libraries, and for 3D graphics in particular, that's all native libraries. OpenGL, for example, is native libraries because it's all written for C originally. And so we have to make do with the fact that we need to have bindings for Java. But they exist, and they've existed for a long time, and they're good quality. You need to know a little bit about linear algebra, matrices, and vectors, so you know how to manipulate coordinate spaces, and how the graphics rendering works behind the scenes. It's good to have an understanding. And I'll teach you about how you're going to set up your game loop, how to set up your rendering architecture, and then finally, how easy it is to handle user input. All right. So first of all, libraries, like I mentioned, OpenGL is at least what I'm going to be using in this set of slides, and that's the Open Graphics library, and that's a portable graphics library that's supported on mobile and desktop devices on Windows, Linux, and I think also Mac. And so it's basically like the equivalent of write once, run everywhere, just for graphics. Um, and with that, we use GLFW, which is a wrapper library that handles window management. So there's in Windows, for example, you have the Win32 API for building windows and things and manipulating things on the screen. But we have a wrapper library that handles that on Windows, on Linux, on Mac, and so all you got to do is just create a window with a title and a width and a height, and you're good to go. Then for audio, we use the OpenAL native library, and that, like OpenGL, is a 3D cross-platform library for um, playing audio. Uh, quite self-explanatory. And finally, I use NanoVG, which is I think it's a quite useful native library for rendering um, vector graphics into an OpenGL context. So assuming you've already got your game running with OpenGL, you've drawn your cube on the screen, you can add NanoVG, and then you can draw text on the screen super easily. You can draw, GUI elements. And finally, instead of installing all of these things separately, you can just install LWJGL and use it as a Maven dependency. And then you've got all these things. Okay. So before we get into any of that, linear algebra. Well, 3D graphics uses a ton of linear algebra stuff, so there's really no way of getting around that fact. So if you don't know it, um, you just need to learn it. That's just a fact. So yeah, it's not hard. It's just takes a set amount of time to learn this stuff. Vectors are literally just 3 floats. A matrix is just 4 floats, and so it doesn't really matter that much about your skill level going into it. So yeah. And in particular, we use affine transformations to transform a coordinate in 3D space to another position in 3D space. And I'll get into that later when we talk about modeling um, individual models in the scene. And you also need to know about the different coordinate spaces like screen space, model space, world space, etc. And finally, it helps to be familiar with the concepts of interpolation and rasterization. Um, so yeah, assuming you've got all that stuff down, what you do next is you set up your game loop. And because we're using a bunch of native libraries that are designed around C, well, everything is pretty much static. Because that's how C was designed. There's no such thing as objects. They've got structs, but that's as good as it gets. Um, so what you do is you call the glfw create window to create your window. And the way that most of these native libraries work is they either operate on some global context or they return some sort of ID or handle to an object that was created. So in the case of glfw, it returns a handle or window ID that we can use to refer to that window anytime that we want to call a glfw function with respect to that window. So what we do is generally in a game loop, you'll create your window, you'll initialize the rendering, which will load up all your models that you might need. Um, compile your shader programs if you had any, and it'll initialize your sound system. And then we get into the actual part, which is the game loop, right? And essentially, you just loop until glfw tells you that the window is going to close. And so glfw knows that because it's controlling, the window X button in the top right, as well as I don't know other OS dependent ways to close a window. And so while the window is open, we clear the screen with gl clear, render, swap buffers, and pull events. First of all, gl clear will do as it says. It'll clear the entire screen. Well, in particular, it clears buffers of certain types. And once we do that, we've got a clean slate so we can render, which is done through render scene. And then after we've done all our rendering, we do what's called swap buffers, because there's a buffer that we draw to, and then there's also the buffer that's currently being displayed on the screen. And so instead of causing a whole bunch of visual artifacts by actively rendering to the screen buffer, we render to an off-screen buffer and then swap it in every frame. And that greatly improves the experience for the end user. And finally, we call pull events, which tells glfw to check keyboard and mouse events and call the necessary input handlers for them. So, in terms of rendering, well, what you generally do is assuming you've loaded your object in the initialization of your renderer, you bind its resources, whether that be a texture or a bunch of vertices that have been stored into a buffer on the GPU. You bind that information, you pass transformation matrices to the GPU, um, and then you draw it. So in this image here from my game, there's quite a few things going on. You can see that the floor, that red and blue area, is made up of the terrain mesh, and that is a buffer containing vertex data for every block on the terrain. So you see those sort of whitish blocks to the left. Each of those blocks has 8 vertices, and that is stored in a buffer. And we bind that buffer. We tell the system that these vertices are in that location in the world, and then we render it. Same thing with the player, their held items, and the flag and the nameplate. It's just the held items and the players and the flag. Those are all objects created in a 3D modeling tool and imported automatically. And then if I go back, you see we call glfw pull events, right? And the reason we do that is because when initializing our rendering system, we set a callback. And in this case, I'm showing you the key callback, which is used, quite self-explanatoryly to handle key inputs. And the way you do this is simply by calling the glfw set key callback function and pass in your reference to the window and then set your callback. And so in this case, every time a key is pressed, we just do a switch case and see which type of action it was done. If it's a press, we call the key press event, and so on. And so if we then look at the next slide, you can see this is exactly how the logic looks like in my game, and it's quite simple, right? If key W then forward, S then backward, etc. It's really that simple, right? So I would almost argue that handling user input in a 3D video game is easier than something like JavaScript or Swing or so forth. But the question is, why are we doing this all in Java? It's native methods, so you essentially have to treat it like fancy C code. And yeah, well, contrary to popular belief, Java performance isn't that bad. Everyone loves to shit on Java because it performs worse than C++ game engines do. However, it's not bad at all. And in fact, Java performs faster than many other languages, and it's easily cross-platform. It's faster to get going because you don't need to worry about memory management at all. You can just go absolutely nuts. You can in the middle of your game loop, you can allocate new matrices every single iteration and nothing bad will happen, right? In addition to that, there's a huge ecosystem, meaning that if you need to get something done, you basically never need to do it yourself, um, because there's a bunch of libraries available to do that for you. For example, OpenGL, there's several bindings available. I chose NanoVG for my 2D vector graphics, but there's plenty of other solutions out there. And as you can see, I've got a screenshot down there which shows me reaching a casual 750 FPS in my game. And this is with, I think, several. It's close to 100,000 vertices with the chunks that I have loaded there. So as you can see, the performance is very, very decent. So everyone says don't do it in Java, but I think that the speed with which you can develop your initial proof of concept makes it worth it. So yeah, that's my short introduction to OpenGL. Thank you for listening. And also, look out for Aether Shades 2 alpha release coming out soon. I can't tell you when exactly that'll be, but should happen soon. All right, Liquid, take it away.
All right, thank you so much for your talk. I
Yep.
think it was amazing. Okay, let me just look at the list. Next up is actually the big rat with Project CODA.
Let me just. Okay. Okay. Good day to y'all, ladies and gentlemen, fellow Java developers. I am the big rat, and I'm here to talk about something new. It's not a. It's not a. It's yeah, Java related, but not just Java. Okay, so you can see that we called it a competitive and speedy outlook to programming. You'll see why. So before I can introduce you, I'm just going to quickly run you through an introduction on competitive programming. So it's a mind sport where participants will program according to whatever the host of the competition will tell the contestants to do. Like something like your boss telling you to do stuff that and you have to do it. So competitive programming is recognized and supported by several multinational tech companies, big ones such as Google and Facebook, even Microsoft too. So one of the oldest contests of competitive programming is the ICPC, which originated in the 1970s, and from 1919 to 1994, 3 people ran one of the first internet-based programming contests inspired by ICPC. Interest in competitive programming has grown significantly since the 2000s, and it is strongly connected to the growth of the internet, especially due to the fact that instead of being at specific places, like for to participate in contests like you had to in the past, you can now participate in competitions in the comfort of your own home or office or wherever that is. So some prominent examples that you may have heard of are Code Forces, Google Code Jam, the Top Coder Open, and Microsoft Imagine Cup. So we've already run through that. Now I can introduce you to speed programming, a new concept that I thought of in the field of competitive programming. So what is speed programming? It's a new constraint put on competitive programming where contestants have to solve the same set of many problems quickly against another until one of them is exhausted or they can't keep up with the pace. And contestants will, in the process, recall data structures and programming idioms and put them into use as they scramble to quickly type solutions to the problems. So what this will test is the contestants' typing speed and mental stamina. So it sounds like a lot of stress, right? We acknowledge this fact. However, what we hope to achieve is to allow contestants to program under pressure. For example, when they have to meet a nearing deadline for work, you have to get things done quickly. This will help you. In addition, contestants can memorize and put into practice common programming idioms. As they solve many problems, they will grasp those idioms and they can use it effectively. And as I said earlier, it also tests your mental stamina and it can train it hard, like really hard. So if I've already run you through that. Now I can introduce you to Project CODA. So what is Project CODA? It's an upcoming programming game that emphasizes the following, which is the memorization and utilization of common programming idioms such as RAII and code patterns such as the factory pattern, which you will commonly see in enterprise code when you go into the workforce. And we also emphasize the rapid solving of problems, which we will from this slide refer to as tasks. This pressure is mounted on players by the game and by other players as they too quickly complete those problems. So how does it work? Here's the flow. A player solves a task by writing code to fulfill the task's requirements and running it against the task creator's provided test cases. And the others had to do the same and keep up the pace to avoid getting knocked out of the game. And as I mentioned earlier, all the players will solve exactly the same tasks. An infinite set of tasks just until there is only one player remaining. And then we also include an element of the community by allowing other players to contribute tasks to the database by writing test cases to check for whether the player has fulfilled the task requirements. In addition, we also enforce that the players cannot spam requests to the server to run their code. So what we hope to achieve is it will allow the server to maintain its resources, especially since we plan to deploy this in a Kubernetes cluster. And we can actually also make sure that the player will check their code before submitting it. So let's just go, some technical specifics. Forgive the last point. Source files are run against their corresponding tasks test cases in an isolated Linux container. Task creators can also use dependency management tools like pip or Gradle when they are writing tasks. So what languages do we currently support so far? We plan to support Java 17, Kotlin for the JVM, Rust, C, C++, D, JavaScript, TypeScript, Python 3, and C#. So matchmaking, one of our selling points. So our official matchmaking system is a 1 versus 1 format. And players will enter into ranked matchmaking queues for one or more languages, which I have talked about in the previous 2 slides, or actually listed. And when a match is found for a language that the player queued for, those 2 players that queued for the language in question will be pitted against each other to solve as many problems until the other is eliminated from the game. And the winning player gains rating, and the losing player will lose it. Just for a bit on rating, it's basically a measure of a player skill. We can't just measure the skill outright. So what we do is we're going to have a player base, and then we will. It's kind of like a bell curve. We will measure the skill of the player from the player base as they play against those players. Forgive me for that. So let's look at, so you can see below on the bottom left, S plus to F, those are matchmaking ranks, and they are awarded to players when their rating, which I talked about in the previous slide, reaches a certain threshold. And they are just a brief means to measure a player's skill level, a cosmetic one to be precise. So let's look at rooms. So players can play casually in rooms without their rating being affected. What we hope to accomplish from including this is we don't want the player to think that Project CODA is all about speed programming, no fun, you have to sweat. No. You can have some fun too, you know? So rooms may have more than 2 players, which contrasts with ranked matchmaking's 1 versus 1 format. And this can be used for events such as online tournaments or get-togethers with other colleagues in work. And so, what's the difference from other sites? So Code Academy is a place for people to learn programming and hone their skills at it, similar to JetBrains Academy. This is not a game. It's something like Udemy, but kind of like a practical. You can like learn. You can learn. Yes, you learn. That's it. And in Code Wars, players don't compete against each other in real time. They actually compete like single player, and they have to solve. They will solve tasks. They will solve code problems. But those code problems are specific to the. They are how should I say? It's all by the. Yeah. Forgive me. So in Code Wars, players will solve problems, and from solving those problems, they will gain something called kata. Kata is not like rating. As you solve code problems in Code Wars, your kata will only increase. The difficult problems you solve, the more your kata increases. This contrasts with Project CODA. Your rating only increases as you win matches against similarly skilled programmers. And then for HackerRank, their code sprints, which are competitions that are held at fixed times, are not like us, because in Project CODA, anyone can play against anyone else anytime, even if it's at 12 a.m. Anytime. And LeetCode is really only a site where you will answer questions. This would help in preparing for interviews yeah. It's not a game. It's really just for preparing for interviews and other cases. And Project CODA is not about learning. It's about putting your skills to the test. Unlike most of these other sites where you will just learn programming, we are about putting you, the programmer's skills, to the test to be able to bear the stress and pressure. And so let's look at the team behind the scenes. I'm Gerard Sason, known as Big Rat, and I'm doing the back end. And we have Finn Berend, known as Liquid. He's doing the front end. So any questions, please ask in the voice chat for Java Talk. Okay, so Project CODA will be for Andrew's question. Project CODA will be released in around a few months to a few months to a year for that, because we have to settle deploying the servers. We have to settle authentication, MongoDB and stuff. Yes, around that time. The Linux container, we plan to utilize the Piston API and run it in a Kubernetes node, so we can easily install language runtimes and utilize it to run untrusted code. Yes, the Piston API. Something like you see in the bot you see the Iran code bot. It uses a Piston API. Yes, we will host a Piston API by ourselves. We cannot outright strain the shared instance, because we're going to run a lot of code. a lot. So any other questions? Yeah, Sam, it's kind of gonna be a startup. L- Liquid's doing the Liquid's me and Liquid are thinking of incorporating in Delaware. And yeah, any other questions? No? Okay, thank you for your time. Sorry, Sam, yes. Uh, pl Please stop with the weird questions. Okay, anyways, thank you for your time, and please enjoy the rest of today's Java talk.
All right. Thank you for your talk. Can you please disable your screen sharing? Thank you. So next up we have Daniel with what various OpenJDK projects are about. I think you can unmute yourself.
Yeah, I'm going to screen.
Okay.
Okay. Okay. Hello and welcome to my presentation about some OpenJDK projects. Short legal slide, I'm not an Oracle employee and I may not talk about everything related to that, and I don't guarantee for anything I say here. So, what am I going to talk about? At the beginning, I will quickly mention what OpenJDK projects are, and after that, I will go over some of those projects, including Project Ember, Loom, Valhalla, Panama, Lilliput, Metropolis, and Project Leyden. So, who am I? I am done first on GitHub, and you might know of me on Discord. I'm a member of the Java Discord for quite some time now, and I'm moderating since the start of this year, and I recently also became a staff lead. And currently I am also doing a bachelor studies in AI. Okay, now let's start with the presentation. And the question what OpenJDK projects are about. From the official projects page, they have the following quote. A project is a collaborative effort to produce a specific artifact, which may be a body of code, a documentation, or some other material. So basically, projects are changes to Java that are grouped together, and it is not done in a way that every single small change gets its own project, but multiple changes or is done in a project together, or that big changes could also get the project. So I have also some examples of projects that you might have heard about that have already been completed. For example, one Java, since Java 9 modules exist, and those were introduced in a project named Project Jigsaw, and famous feature of Java, Lambda expressions, those were also introduced in a project named Project Lambda. And there's another project, Project Coin, which introduced language features like the private resource explorer for the diamond operator on generates. Now, let's come to the part you all are here for, the actual project. And I will start with Project Ember. Again, I have a quote from the project page. The goal of Project Ember is to explore and incubate smaller, productivity-oriented Java language features that have been accepted as candidate chapters in the OpenJKD chapter process. So basically, Project Ember wants to give birth to new language features in Java that increase the productivity of development. And the acronym JEP stands for Java Enhancement Proposal. First change or feature I will talk about is sealed classes. Those are fully available since Java 17, and this was finally specified in Java Enhancement Proposal 409. This adds a new modifier, namely sealed, which is valid for classes and interfaces. Such sealed types can only be extended by types that are permitted. We'll see what that means in the next slide. And those permitted types that are extending the sealed type need to be sealed, final, or non-sealed by themselves. So now, how does this look like? It basically looks like this. First code snippet is a sealed class, which permits 3 other classes. Before the class keyword, there is another modifier named sealed, and the modifier makes it a sealed class, and the class explicitly permits subclassing by 3 classes: final subclass, non-sealed subclass, and sealed subclass. And the sealed class could be an interface as well. It is only possible to extend this class if the subclass is either final, as in the second snippet, non-sealed, as in the third part of code, or sealed itself in the fourth part of code. In the last bit of code, you can also see that it is possible that another class extends the sealed subclass of the first sealed class. And if a class is non-sealed, it basically means it is like any other class, so other classes can extend a class like they want. Now, let's come to the next feature. And this feature is called records. Records are available since Java 17 as well, and were introduced with chapter 305. Records are a new kind of class for mutable data, and the records are created by using the record keyword instead of class. And when creating a record, all fields of the record are implicitly final, and it is not possible to create a subclass of the record. All components, so basically all fields of a record automatically have getters, and those getters have the name of the components themselves. And it is not possible to create fields that are not record components, as you will see in the next slide. There's also an implicit constructor, the canonical constructor, that has all record components, and records automatically have a good implementation of the equals, hashcode, and toString methods. So here you can see the declaration of such a record. In the class there is the keyword record, and fields, the record components, are not written like one normally puts field, but they are included in parentheses before the actual class block. Starting from line 2, you can see the canonical constructor of the record. If this is a shorthand for the canonical constructor, if no arguments are and in parentheses are added, it will automatically be a canonical constructor with all arguments. And in here, it is possible to check the values and validate them and throw an exception if something is not okay. This is an example how those methods can be used. It is possible to instantiate them like any other class and get the components by calling the scatters. And as you see, those scatters have the same name as the record components, and there's no get prefix in them. They also have a toString method that will print the components. This will be used in the core here. And when creating a record with invalid arguments, that will do an exception because the code is now I will come to pattern matching for instance of. This is fully available since Java 16 and specified in Java 100 proposal 394. It allows to combine instant checks one does with instance of with the cast, and this looks like that. One does an instance of check. Instead of casting explicitly after instance of check, one can combine the instance of check with a variable declaration by putting the variable name directly after the class name in the instance of check, and it is possible to use the automatically casted variable right afterwards. After pattern matching for switch, there is another feature introduced with Project Ember, and this is called after pattern matching for instance of, there's another feature, namely switch expressions. They were introduced with tab 361 and are fully available since Java 14. Switch expressions, as the name already says, allow to use switch keyword as an expression. And they also add a new keyword, a yield keyword, that allow returning the value inside that block in the switch expression. And an important thing to note about switch expressions is they need to be exhaustive. As what switch expression look like. This here switches over a string, and if the string is hello, it returns the value hi. And in a default case, multiple lines of code that are executed, multiple statements executed in that, and the value is returned with yield period in line 6. Result of the switch expression can then be assigned to a variable, as you can see in line 2. Another feature of Project Ember is pattern matching for switch. This is currently not available as actual available in the fully. This is currently a preview feature since Java 17, and it is still subject to change. The traps specifying pattern matching are traps 406, 420, and 427, respectively for Java 17, 18, and 19. Pattern matching for switch allows to use the text and instance of inside of switch statements and more things. It's just like it is possible with pattern matching for instance of. And pattern matching for switch is also compatible with switch expressions. And another nice thing about pattern matching is that it is possible to check for null inside the switch itself instead of throwing a null exception. So look like you can see in line 2, it is compatible with switch expressions. It is possible to take your hint from the switch field expression. In line 3, you can see that one can create and check if it is a string and also assign it to a variable. Do something and for values. Another feature that I would say is not talked about is called textblocks. Textblocks were specified in Jet 378 and are fully available since Java 15. They allow to create strings over multiple lines without using string concatenation. This looks like this. One puts 3 double quotes, then a string that spans over multiple lines, and at the end they put 3 double quotes as well. And one doesn't have to end the string concatenate with the string. Type influence. This was introduced in 2010 with Jet 286. It basically allows to replace the variable type on the left side with the var keyword, so that one doesn't have to write the type on the left and on the right. It only works if the type can be inferred from the right-hand side, and it also only works with open variables. Code for this would look like that. One can create a string using a literal, for example, on the right-hand side and assign it to a variable on the left, and then newly create a variable on the left-hand side. And since the type of literal is known, it is possible to use var. This also works with generics, as you can see in the second example. Now, after finishing with Ember, I will talk about and from the note from the official side, from the project. Project Bloom is intended to explore, incubate, and deliver Java VM features and APIs built on top of them for the purpose of supporting easy-to-use, high-throughput, lightweight concurrency, and new programming modules on the Java platform. So basically, Project Bloom is about big change in Project Bloom. It's available. Then there was a preview feature in Java 19, so it will subject to change, and those are specified in Java. Virtual threads are new, and it is possible to create lots and lots of virtual threads without spending much resources, like memory and so on. It is because those virtual threads are so cheap, there's no reason to reuse virtual threads multiple times or to cool them, because they can be created and thrown away without much. Threads use billing internally, so that means that few platform threads, so real threads, will be shared by many and many virtual threads. So you can have 500 virtual threads that share 4 platform threads together. And while one virtual thread is blocking, it is used by other platform thread can then be used by other virtual threads. Doing this, a new API is added to Java, the thread builder API, and this creates 2 thread builders that can be created with thread.platform and thread.virtual, and there's also another executor service that can be created using the factory method new virtual thread pass execute. This will then look like this. Virtual thread is created using a thread builder. The thread.virtual method creates the thread builder. Then it is possible to use name, and after that, thread can be started using the start method, which returns Similarly, it is possible to create an executor service using the executor.view virtual task executor factory method and submit tasks like any other executor service, but every task will be its own virtual. First, virtual threads come with a few limitations. For example, it is the operations like when operating on intrinsic blocks, so using when waiting for synchronized blocks, and when calling into native code, the actual platform thread is blocked, and it is not possible to reuse that platform thread for other virtual thread during that time. Also, no improvement in using threads when all the tasks that are submitted are CPU bound. When one has a thread object and is accessing it from many local threads, that will consume resources because the thread local is different for every thread. Aside from the thread, Project Loom also adds another feature, namely concurrency, which is an incubator module, meaning it is not fully available yet, but one can try it in Java 19. It is specified in Java 19's proposal 420. Market concurrency is a new API for market bidding. It is based on the class structured task, which is responsible for creating multiple tasks. There's a method called which just submits tasks, and there are multiple implementations of the structured task scope, with, for example, shuttle on failure and shuttle on success, which do exactly as they say. Shuttle on failure stops all tasks if the first one fails, and shuttle on success shuts down all tasks if any successful. In the first line, new task scope is created, and this is a success scope. And it is possible to submit tasks using a fork method as shown in line 2 and 8. In this case, the second task will finish earlier because it doesn't sleep that long, and the scope is joined, so it thread waits for the scope to finish. And because it shut down success, it will only wait for the third task to finish. Similarly, it is possible to create a pattern on failure scope by changing the pattern success to failure in the first line. Most of the code is basically the same, but when after calling time, there's another method called throw if fail, where it throws an exception if any of the tasks fails. Now, after finishing the room, I will continue talking about Project Valhalla. This Project Valhalla, again, I will go to the project page. Project Valhalla plans to augment the Java object model with value object and use-defined primitives, combining the abstractions of object-oriented programming with the performance characteristics of simple primitives. These features will be complemented with changes to Java's generics and preserve performance gains through generic APIs. So typically, Valhalla will introduce value objects, public primitives, and unified generics. Most things are highly subject potential. Start with value objects are inline types. Those are currently submitted chapter, so they don't even have types are typically in new kind of type. So they are reference types, but all of the fields are binary. and when someone wants to change them, you need to reassign the equals operator, where you compare the values of the value object and not the references. It is not possible to use value object of initialization. There will also be two new identifiers for types, namely the value for inline depending on this is change one modifier for making a class value to class interface value type and or an identity is should and using value and interfaces class and records would be value. This one adds a value modifier to a class or maybe inline dependent thing on the look like. And one can code. All of the fields are defined. It is also possible to create feature project HANA process is projects. They are also not yet available, and they should be specified in candidate chapter 401. New objects are another new kind of object which is similar to value. Complex primitives are another new kind of object which is similar to value objects, but the complex primitives are not reference types, they are value types. As with value objects, all fields of complex primitives are binary, but the complex primitives can not be null while value objects can be null. As with value objects, the equals operator compares values and not the references, and it is not possible to use complex primitives for synchronization. Aside from that, it's also possible to create arrays of complex primitives. Another thing to note about complex primitives is that they have a reference representation. It is possible to obtain that with the operator. So this representation is nullable, and it is like the integer robot task for int. How can one create a complex primitive? So basically, they like a value object, but instead of value, one task uses a modifier primitive. And then we use like this. One can just create them, but it is not possible to set the reference to null. Create it, but if one obtains a reference representation by just assigning it to another value from the same type but with that operator, like shown in line 3, it is possible to assign that reference representation to null. And it is, as you can see in line 5, and line 6, it is possible to create arrays of both the primitive and reference representation. And when creating, and since the primitive arrays cannot have null elements, they will all be initialized with complex points where all variables are 0. Project Valhalla also aims to introduce a feature named classes with basic primitives. This is typically wants to change the primitive robot classes to be reference representations. Integer would basically be int. It is not a Project Valhalla also wants again Java, which is one of the dynamics. Currently, it has a submitted chapter, so it doesn't yet have a chapter number, and it is not yet here. universal generics allow to use generics for primitive types, and this includes complex primitives and non-pair-normal primitives like int. So both of these can be used in generics. So it would then be possible to create, for example, a list of int and not just a list of integer. Hello. Now talking about again from the project page, put something. We are improving and enriching the connections between our Java virtual machine and well-defined but for non-Java APIs, including many interfaces commonly used by C programs. Basically, accessing the first part of Project Panama is the foreign memory, foreign function memory API, which is introduced first in Chapter 124 in Java 19, but it is a preview feature, so not yet fully available. Still subject to change. And there are earlier versions of that, but previously it was split into two incubating API chapters, which were the foreign memory API, which was available as an incubating and the linker API, which now that it's a preview chapter, it is it's a foreign function memory API. Basically, it's an API for accessing the controlling native code and accessing native memory. And in theory, what does it look like? This is some code I wrote, right? In the first line, it creates a linker object using linker.native linker. Then it is a symbol lookup object is created using the default lookup method, which represents the standard library. Then method handle is created for the D function using the method linker handle. Parameters on our last reference method, which is obtained using the lookup method in the symbol lookup class, and the function name is password. And since it returns an optional, one needs to get any second parameter of download handle is a function descriptor which represents the parameters. In this case, the strlen requires a string, which is an address, which would be an address in here. So, and in 64-bit Java, addresses are 64-bit values. So, it is a Java. And in line 6, it starts with allocating, preparing for allocating memory using creating a second allocator using the memory method implicit allocator. Then in line 7, the string Java string is converted to a C string using the method allocate UTF-8 string in line. It returns a memory segment pointing to a string in C to a native C string. And line 8, string len function, the native string length function that was obtained previously, is then called using the signed right from the function memory API. Project Panama also brings the vector API. Those that was specified in 338, 414, 417, and 426 for Java 16, 17, 18, and 19 respectively. So it was available as an incubating API since Java 16, and there is not yet fully available. It's the vector API, just like the name says, it is an API. Code using that look like who is upgraded, and then in line 4, a new vector species is obtained. A vector species represents the type of vector. In this case, it uses the vector species whatever it is also possible, for example, create line 5. It is possible. The code creates a vector mask, which specifies which bits are actually passed to the vector, which elements are passed to the vector and which are not. In this case, I'm using the species is passed to the from long method, and the 0x means line 6. Vector is created using interactive programming. The species is passed to that, and also the array where it takes the elements from and creates a vector from it is passed. Then the 0 in there means it is the offset, so it starts with the element of the array called first, and the mask represents which elements should be taken. And in this case, it takes all elements of the array. Then in line 7, vector that was obtained in line 6 is multiplied with a scalar 2, so all elements are multiplied, and it is play again and print. So in this case, this will print 2, 4, 6, and 8. 8, another vector is created from the second array, and then those vectors are added in line. Now that we finished with project Anima, I will come to 3 other projects which do not aim to create new APIs or language features, but improve the JVM as a platform. Last thing here is Project Lilliput. Again, from the project page, the goal of this project is to explore techniques to downsize Java object headers in the hotspot JVM from 128 bits to 64 bits or less, reducing Java's memory footprint. Improved performance across most, if not all, workloads is also expected. So what does it mean? Basically, Java currently requires 128 bits of metadata, just metadata per object, or in might also be 96 bits. All of Project Lilliput is to reduce the amount of metadata to 64 bits or maybe even 32 bits. For level objects, there's what also this collector, and never Java application will also memory. But from this, because of the Scout collector work and so on, performance is also expected. The nice thing about Project Lilliput is that reducing the object header to 64 bits is already achieved this year. Now let's move to Project Metropolis. Project again, I have a project page in here. Project page. The goal of this project is to provide a venue to explore and incubate advanced Java on Java implementation techniques. Our starting point is earlier proposals for using the Graal compiler and ahead of time set the compilation technology to replace the hotspot server technology, and possibly other components of hotspot. It is supposed to implement big parts, significant parts of Java in Java itself, so that for example, mainly the JIT should be written in Java. This should even improve performance of Java application and especially simplify the implementation of JVM itself. And it is based on existing RVM resources. Finally, I have one last project to talk about, namely Project Laden. This Project Laden, again, project page. The primary goal of this project is to address the long-term pain points of Java slow startup time, slow time to peak performance, and large. Basically, they want to improve the JVM startup time and the memory footprint. This could be done using static images. Those static images are like the stuff Failing creates. So there's basically images of the application that can be executed, and they only contain the application and nothing more. And it is also not possible to do class loading at runtime when using static images. So static images are kind of a compromise between Failing JPackage and GraalVM's native image. Static images would be better when the scope of performance and Failing, but with less restrictions on the application than it is with GraalVM's native image. If you want to know more about the stuff I'm talking about, you might want to look at one official Java website, namely Inside of Java. And if you have questions, just write them. So, were there any questions? Why use the vector API over classical Java computations? So, when doing all the stuff in Java, it may be a bit slow because it doesn't use the especially when multiplying huge arrays with each other or similar. While the JIT may optimize it to use CPU vector instructions that may not be that reliable. And those vector instruct, and when using the vector API, Java guarantees that those CPU vector instructions will be used. No, this is not. It may be integrated into InStream, but it is basically another API. But who knows? Maybe it will be. Maybe InStream makes use of it. Are there any more questions? Yeah. Thank you all for listening.
All right. Thank you for your presentation. Okay. So next up is Pace with bytecode manipulation and reverse engineering. You can unmute yourself.
I was not aware of that I'm muted. So today we are gathered. So I'm going to give you a presentation about bytecode manipulation and reverse engineering. So to get into the bytecode manipulation first, we have to look at what is bytecode. So when we take a look at bytecode, we must know how it works. So let's say we wrote code in Java. Let's say this is a code block to print hello. And this is our computer, and we have to run it through our computer machine. So this is our machine, and to run it in Java, there is a middle linkage that we call bytecode. So before, let's understand what these things are. So where your Java code have a Java extension, as we all know. Bytecode have .class extension, and the machine code is just a bunch of binary stuff, bits. So that is bytecode briefly. So let's dive into bytecode. So first, to get a better understanding of bytecode, we can use things. Like for bytecode manipulation, there are a bunch of libraries such as Object-based ByteBuddy, Java Assist, and more. So by using first, let's get how bytecode works. So bytecode is nothing more, but it's just a set of instructions. Can you hear me clearly? Okay. So bytecode is just a set of, let's say, talks or instruction that into a stack. So stack is a very important thing in it, and a local variable table. We will take a look at these in a bit. Let's first get an understanding of bytecode. So the bytecode, I've told you already. If we take a look at stack, the stack can be thought of as a list of operands. There is a stack table and a local variable table. To get, let's say, an example. Let's say we have two integers. Let's say we have two ints. Int a, that is 2, and in b, integer b, that is 3. So 1 is 2 and b is 3. And we have to add it. We all know that the addition operation can be used here. So how Java will add it? So there are stacks. If Java were to perform 2 plus 3, it would push first 2 onto the stack and then push 3 onto the stack and then performs an addition operation that will give us 5. And the operands, and stack is a list of operands, and these operands isn't needed. It will just pop in off. So be careful that this is called pop. They will pop it off. The stack that this operands holds can be similar to an array of list and operations carried. The stack will hold these operands similar to an array where list or operations carried on the stack will operate on the topmost operand of a stack. So I know no one got this, but let's get this. So let's say that this is our stack. Let's say that this is stack. And let's say this is a position. And this is operand. So the position is 1, 2, 3, 4, 5. So and the operand. So what we are initially doing, 2 plus 3 equals to 5. So how this is going to work is it will first push and 2 into the topmost of the table as 2 here, and then push 3. Be careful that the stack always gets pushed on the first place, on the first position. So it is going to push first 2, and then going to push 2 down, and then 3. And then it will add them. Yeah, it will add them thoroughly. So first 2 gets pushed onto the stack, 2 below, then 3 get pushed onto the stack. And then it is going to add and give us a 5. And let's say we have to add another 5 to, let's say that this will be our result. And add 5 to the result. So as the stack obviously puts at the first position, it will play 5 and then another 5 and then add them, which will give us, oh my god, which will give us 10. And when these values are not needed, it will just pop. We use term pop here. Pop is just deleting this, just getting this out of the stack. And there is also a thing called swap. So be careful. We are using three terms here. So first is push. So second is pop, and third is swap. So this is the first, this is the second, and this is the third. So what the swap is that we have an operand as 2 and 5. So it is just going to switch the values. So these values will get switched. So this means that 5 is going to on top and then 2 here. So why do we need swap? So why do we need swap? So let's say we have to pop 2. So say we have to pop this value or remove it from the stack table. So we have to pop 2. So how we are first, if we are doing this normal way, we first have to pop 5 off, then 2 off. If we don't need to do that, we can just swap this. 2 was here, 5 was here. We're just going to swap these between them. So after the swap is done, the 2 will go into the top and then 5 will go here. So then we can pop 2 safely by this. So this is just an example of how stack works. Yes, that is a quick math. Okay. So now we have now we get the things of how to save variables. Yes, Linux is true. Dax is true. So now we have the thing of on saving variables in bytecode. So there is also a thing called local variable table. Local table. And the local table stores values and is referenced by the index like an array. So we all know what is an array, like A, B, C, 6. If it wish to save a value, I can just ask it to store in it and say the index is A. And if I wanted to retrieve it, I would ask it to load from an index, same A. A stack and a local variable table and a reference to the runtime constant pulled together is known as a frame. Yes, note that. A stack, it doesn't have text. Yes. So, oh my god, this is so, never mind. So, a stack, what is going on? A stack, a local variable table, and a reference. Reference to the, be careful that it is a constant pool, runtime constant pool, runtime constant pool. This entire thing, this thing is known as a frame. Frame. Okay. Then let's take a brief look at manipulation. So when we are manipulating our bytecode, we don't need to worry about the runtime constant pool. And put this in your vision that frame is created every time when we call a method. Let's say for an example, let's say have a method loop. We have a method loop, and when we are calling this, when we are performing a method call, a frame would be created. A frame will be created. Now let me give you an example of frame. No, a local variable table and a stack. So for this, let's create the stack of this thing. Just do this, whatever. And this. Oh my god. This, that, and that. Let's say this is an index, and this is with the value, and this is position onto the stack, and this is the operand. And let's say that we want to push hello. This is another term that we're using, push hello or hi. Just so it will get pushed onto the stack table. So 1, 2, 3. My bad. 1, 2, 3, 4. Now be careful. The local table starts with 0. 1, 2, 3. Let's say we pushed high, and then if we ask the local variable table to store another term, store 0. So then this high that is on the stack's first position will get stored into the 0. So this will store high here. And if we push another thing such as people, it will get pushed onto the operand people. And no, wait. This will stop places. High will go onto the second place, and people will go onto the first place. This does not have an eraser. Is my voice clear? Can you hear me? Can you hear me? I like that. I loved actors and stack. So let's say we pushed high, and then we again pushed people. And we asked it to store high onto the 0. So this will go have a high, and this will have a high. This is the first thing that we're doing, and this is the second thing that we're doing. So people will get pushed here. And when we asked people, when we asked this entire thing, the frame, to store people in the place, so now it will store in here. And then we just push hello again. This place will go to, this will go down here. This will take the second position, and the first position will take hello. And when this thing is very important to learn. That's in stack. If you push anything, it gets into the first place, in the upmost place. Even if you pop things or push things, it gets onto the first place. And so that's it. And there's another thing I forgot to tell you. That is load. What load do is just store. It's opposite. They're just inverse of each other. When loading, when I say load 0, it will load in here, and the second thing here and here. So this is the entire loading thing. So this next topic comes is what should I tell? Method invocation, yes. Method invocation. Method invocation. To invoke a method, you must first have the parameters in the stack, then invoke the method. If you're calling a non-static method, you must also push the instance you're invoking the method before the parameters. And when you call the method or after calling the method, the parameter and the instance are popped off the stack and or either replaced with nothing. In nothing in Java we use void or a void method or replaced with what it is returned. So that's pretty much method invocation. So I said that to invoke, if you're calling in a static method, we must push the instance that I am invoking before the parameters. Let me give you an example of that. So let's say it does not have a text, it would be better by this. My handwriting is quite bad. Let's say add a text right here. Let's make it bigger. So, oh, well. Yes. So let's say we have a non-static method that it is x is equal to the b, and okay, never mind. We can use a here. And a split. Oh my, whiteboard is not autocorrect. Let's say we have this method as a non-static method, and the instruction that we're giving are the instruction that we're giving is push. Yes, let's first take a look at push a b, then push, then we're going to invoke it. So that now when we take a look at the stack, where is it? I hate running stack. At least this gives me an autocorrect region. So like this. So position 1, 2, 3, operand. Can you hear me? Can you hear me? Okay. Okay. So let's first push this a plus b, a dot b, and then we push this dot. So a plus b goes on to the second position, and dot goes here. This thing actually goes here, and this thing goes into an set, or this, right? And when we invoke this string dot split, it just uses it as set there, invoking a string split. So that is just this in a short time. This is a fast pace shit. So now let's take a look at how bytecode is generated. The generation of bytecode. Bytecode generation. Bytecode is generated by the Java compiler and interpreted by JVM. So there are two terms to look at: compiler and JVM, Java Virtual Machine. I think that everyone here is familiar with them. Yeah. Okay. As I told you earlier, bytecode is a set of instructions, and each instruction comprises an opcode. Opcode is 1 byte. Opcode, along with 0 and more bytes. More bytes as a parameter. An opcode is the type of instruction being carried out. Given that an opcode is 1 byte value, there is a space for 256. 256, specifically 256, a type of opcodes. Opcodes. However, there is only 198. Yes. Okay. 198 of these values are currently in use. An example of a parameter that can pass is an index to a local variable or constant from the constant pool. There are 198 types of these, and in this short time of limit, I cannot tell you all of them, but let's go in fasting. The I is an integer. Booleans are also represented as integer 0 and 1. L is in long. It can take up to 2 slots. S is a short. B is a byte. F is a float. Clear the canvas. F is a float. F is a float. D is a double. It also can take up to 2 slots. And there is A. A adds an opcode, such as for reference. And now let's dive into the more specific ones. So there is a constant null. Okay, I'm not using this. No one can understand that. Is anyone getting what I'm speaking, or are you just ignoring me? Oh yeah, at least Ben is getting. So there is a const underscore null, and it takes up to 1 byte. And what it does is just loads null on the stack. There is another thing such as I const 0 that takes 3 bytes. It just loads 0 on the stack. And there is this thing goes like till, let's say, 0 1 0 1. There is fconst iload index. Okay, let's talk about iload index. So what iload index that takes 15 bytes. What it does is actually pretty interesting. In contrast to this, this thing tells us to that, and this thing just loads integer from local variable table. Yeah, it just loads from a local variable table. There is iStore index that stores the local to the local variable. There is IDC index that takes 12 bytes and loads constant from index to the constant pool. There are a lot of these things that are going around. There are a lot of operands. So this is just how bytecode works. I haven't showed you any real bytecode, so let's dive into the bytecode thingy. Okay, so let's get in. Can create a new pull request, a remote fill. Okay, that is just a little thing. Yeah, wrong channel, mate. So let's now dive into this. Okay, so let's say we wrote a code. Oh my god. Say we have a code. Let's say, what was it? Let's say public class hello. It does not have indentations, bro. Say hello. Public static void main string bogs. Oh, what? Help me. So let's say that this is our code. This thing, this thing has a code. So when we look at its bytecode, I've coded this so much, I know the bytecode now. So when we take a look at the byte, oh, what is going on? No, that is too small. Yeah. So when we look at the bytecode, it will be okay. This thing will be the bytecode. So public class me dot paste. If there's a package, in my case there was, but now it is not, and now it's now public. The class hello. If we have a constructor, it will just go hello world or hello this, and this is the exact bytecode that will pop up when you do Java P and your class name. So this will be the code 0 load underscore 0 1. When we look at this 1 2 3 4 that is common, that is the stack. That is the position on the stack. 0 invoke special hashtag first. Now I will strictly jump to fourth because there is a fourth on the return. This thing is very deep. The subject is very, very deep. Don't make any jokes. I cannot teach you the entire bytecode in like a span of 30 minutes when I have so much technical difficulties. Am I audible? Am I audible? Hello? Okay. So, as I was saying, I cannot teach you the entire bytecode in some seconds, but this is the best I'm doing. Get static. 6 second. Third. I don't care. No, it's actually IDC. Third. That is not B semicolon but a colon. This sucks. Invoke virtual. Fourth. And then finally on the 8th, this will return. And the code will end here. So there is also a class. Public class hello that will store this entire thing. Okay. Okay, I'll come to the end. So this is our walkthrough. This code produces this bytecode. So what we're seeing is just, you can see that there is a frame. We're pretty much looking at the frame for the constructor of the method. I have to make a frame first, bro. You can just assume it in a mind. I think everyone here is experienced with Java. Yes? Is anyone even listening? Okay. So this is the walkthrough of a bytecode. This is the bytecode that we're getting. There will be a runtime constant pool. there will be another local variable table for a hello world, and there will be a stack for the same. So I don't have much time left. So let's get through the end. There are a lot of descriptors. When we are looking at things, there are some descriptors. Since you can have multiple methods and fields of the same name in a class, the way that bytecodes differ them by referring to the descriptor. A descriptor describes what type of field value it is. For example, the descriptor of an integer will be an L. No, it's capital I. Wait, was it L? So the L use. Oh no, it's for a class. Yeah, L class. Sorry, my bad. So it will be a capital L. And B, put this in a mind that every descriptor will be a capital method, capital letter, capital. Integer will be an I, or a Boolean will be Z. So let's use this in a text. So let's say it's the type of class you need to put to the path of it. For example, if you're taking class, you've seen a lot of things. Let's like ljava slash lang slash string or slash lang slash object in Java. Yeah. So I'm going to write types on the left hand side and the descriptor on the right. So for a void, it is capital B. V. For Boolean, it is a capital Z. For a character, it is a capital C. For a byte, it is a capital B. For a short, it is a capital S. For an int, it is a capital I. For a float, it is a capital F. For a long, it is a capital L. No, for a long, it's capital J. I keep forgetting about the class and the stack things in the stack, let's like L index, Okay, so where were we? For long, it's capital J. And the example goes long. For double, it's capital D. For a type, though, for a type, it is type, just this, without any of that. So let's use it in text. So for double, it's capital D. For a type, where is it? It's type. And finally, for a class that I've been most confused with, it is a L and then the class's name. Class's name. And that is our N. So these are pretty much descriptors. There are also method descriptors. We're going to take a so there's an agenda, but we'll post and talks voting channel. Okay. Yeah. The double is D. You're correct. Last word. So now, when we talk about method descriptors, they also have a descriptors which look like somehow what they let's say we have a method descriptors org types ret type. When the org types are descriptors of the argument and the ret types is a descriptor of what it is returned. If a method are like something close to this, let's just say with a public, let we have a public string method anything. Let's say we have integer x and a string y. String y. Then the descriptor that we're looking for will be something like close to this Java slash lang slash string. Where is it? A semicolon. Then L Java does not look good to me. L Java slash lang slash string. This will be descriptor. The archetypes are the I. The archetypes are I. What is that? So that is that. The archetypes are I. And that L Java thing that I wrote was a string, where the thickness of it is low. All plus double plus 1. So the L Java thing I wrote will be the descriptor of string and the method. And let's say we have a descriptor somewhat close to what should I take in? What is this? Let's say we have a descriptor like I L what game Age of Spades, or let's say just Minecraft. Yeah. Let's say we have Minecraft class name world. Let's say, or a Minecraft. So the thing that this will look like will be a mine net, because the we have to first fetch the package that will be world, and there is a semicolon, this will end, and a void. So this, if the descriptor looks like if the descriptor look like this, then we can actually reverse the method, reverse engineer the method. The method will be public void, as it is the v, public void method. Public void, there are three integers. So let's just say x and y and then z. What is the z? And the world is also as a descriptor. So world will be a. So this is what the descriptors, the method descriptors look like. So now we can talk about. Oh, my time limit is very long. So if I get chance another time, we will talk deeply about bytecode manipulation. This entire lecture is for about bytecode. So let me tell you what is a bytecode. ASM. So ASM stands for ASMifier tools. ASM is a library which enables us to modify the bytecode, and it comes with a lot of deep documentation, so you can transform your classes. There are a lot of plugins, such as I use an ASM outline plugin in IntelliJ. You can also use it in Eclipse to view ASMified version of the class, very similar to the bytecode. So this is just a bytecode. There are a lot of things to bytecode manipulation. Most of them are used to object. My favorite ones are object web, ASM, but there are also some things as ByteBuddy and Java Assist. So that is that. I know I've rushed through the entire thing because I don't really had big time. This thing has gone really well with some difficulties, but I've told you a lot of things about bytecode. If you listen me well enough, you would be familiar with bytecode, and you can reverse engineering a lot of clauses. So that is that. Thank you for listening. Any questions? Any questions? It's my bad that I didn't made any slides. Thank you. If this thing happens again, I'll talk a lot about reverse engineering and bytecode manipulation. I had some examples of them right beside my back, such as monitors. So there were a lot of descriptors. They're not that hard to learn. They're very, very easy to learn. It took me around an hour or two. So there are when we why bytecode is important. I just wanted to tell you why bytecode is important. So when we look at Java language and bytecode, there are things we can do with bytecode and not with the Java language. Some of them are monitors. Yeah, monitors. You can take a monitor from a method and use it in another, but Java don't let us do that. So yeah, there are Kotlin, Scala, Groovy, a lot of things. Yeah. Oh my God, Kotlin JVM. That's another topic. Uh, if this thing happens again, I will be very happy to tell you about mappers, how to map a bytecode or how to reverse engineer it. But keep in mind that bytecode don't let us. Yeah, one can use logs, and monitors. That are just a controversial topic. There are locks, deadlocks. Yeah. So that is that. Daniel, do you want me to tell you about locks and monitors, the difference between them? Do you? I'll be very happy. Okay, yeah, maybe next time. I will just tell you through the chat. Okay, thanks everyone. Goodbye. Have a nice day.
All right. Yeah, thank you everyone for your submission to the Java talk today. I will provide the votings later in about 3 or 4 hours because I have to cut all the recordings first. Yeah, we will ping the event ping role too, so you get notified. Yeah, thank you everyone, and yeah, I guess we will see you in the next time. Thank you.